In my free time, I've been able to organize a few things, and I've set up something spontaneous for Friday. I have the unique opportunity to ride along with an overhead line truck. Everyone seems to have an opinion about these, but no one really understands what goes on behind the scenes. So I'm going to experience it firsthand, and I'm really excited to share it with you. Good morning. I started today at 5 a.m. and drove about an hour to my first loading point. I loaded some special construction parts and the trailer is completely full. The plan was originally to head back to pick up more goods, but there's no room left. So now I'm heading 800 kilometers or 500 miles to Lake Constance. It's a nice long distance trip and I'll unload everything tomorrow. I've already found an Ionity charger for my first rest break. But the interesting thing is the comparison between Aral Pulse and Ionity. I usually charge at Aral Pulse because you often don't need to unhitch the trailer. However, it only offers 300 kilowatts, while Ionity requires unhitching but offers 350 kilowatts. I calculated how much time the unhitching process would take. If you charge for an hour, Ionity would provide 50 kilowatt hours more than Aral. To make up for that extra energy at Aral, you'd need about 10 minutes of additional charging time, roughly the same amount of time it takes to unhitch and reattach the trailer. So in the end, they're relatively equal when everything works perfectly. But the catch is that Ionity is cheaper, 39 cents per kilowatt hour compared to 50 cents at Aral. That's why I'm heading to Ionity now. It's a service area with 4 charging spots, which is always a bit tight, especially around midday, but we'll see how it goes. And I've officially arrived in the trucker world because I got myself a trucker sign. I figured nothing suits better than the name Electro Trucker, so that's what I went with. It's also a clear sign that I wasn't forced to drive this truck, but I actually enjoy it. We just had our first traffic inspection. I was stopped by BALM, the Federal Office for Logistics and Mobility. I instantly got nervous. I mean, I have nothing to hide, but you know how it is. Your mind starts racing, wondering if your driving times are in order and the load secured. I followed them into the rest area, parked next to them, and when I opened the door, the officer said, "Ah, an electric truck." Apparently, they noticed I didn't have a toll device, but since electric trucks don't have to pay tolls yet, it was no issue. They just wished me a good trip. No other checks were done. It's funny because the truck has electric written on it in huge letters, and now it even says Electro Trucker. So, my first inspection turned out to be quite uneventful, which is great. If they always are like this, they're welcome to stop me anytime. I just made my first charging stop after 350 kilometers or about 217 miles. I arrived here with 40% battery, which is incredibly efficient. Overall, that means the truck could achieve a total range of 600 kilometers or 373 miles. This efficiency is partly because my trailer is only loaded with 10 tons, and I didn't need the air conditioning since it's not hot outside. What's less ideal is this rest stop. It's quite small, and you can see how tightly packed the cars and trucks are. When I arrived, everything was full, and some trucks parked behind other trucks. While that's not immediately an issue, it becomes a problem when the front truck leaves and access to the parking spot is blocked. I had to carefully reverse into the spot, but it worked out in the end. I plugged in, and the charger is hitting a peak of 350 kilowatts. Unfortunately, it occasionally drops to 330 or even 315 kilowatts. Still, over 45 minutes, I'm getting 230 kilowatt hours, which is plenty to reach my next stop. Some of you commented on the flickering speedometer. Thankfully, since the last reboot, that issue has resolved itself. And some also pointed out that the steering wheel is misaligned. And no, it's not the camera angle or wide lens. It really is misaligned. Honestly, I'm not too picky about it, and you can get used to it easily, but it does fit nicely into the overall vibe of this truck. Technically brilliant, but the small details feel like an afterthought. Who knows? Maybe there will be a software update for the steering wheel too. I'm currently on the A67 heading south, and there's an Aral Pulse truck charging station along my route that I've been to before. It's a good location, but I'm trying to optimize a bit. I still have enough range and driving time, so I'll push further south to an Ionity station. The downside is that it only has 4 charging points, which were all occupied earlier. That might seem problematic, but I see it positively. At least all 4 are operational. I've been keeping an eye on the station, and now 1 spot has opened up, which is great because it means there's no queue. I've got time to spare and will arrive at my destination early tomorrow anyway, so even if I have to wait, it's fine. And heading to the predictable and safe Aral Pulse location would be too boring. I've arrived at Ionity in Bruxelles and got lucky. There was plenty of space, and the charging station is working perfectly. After 6 p.m., rest areas are so packed you can't even find a spot to park the trailer. I barely managed to place it in the front just now, but usually there's still some free space if you scout ahead. It's really worth taking a few minutes to walk around before parking, But luckily there's no truck parked next to me charging, so this setup should work for a while. I've already let the customer know I'll be there tomorrow at 8 a.m. So starting from Lear and heading to Lake Constance with an electric truck is absolutely no issue. I'm charging it to 90% now until the charging speed drops. I'll probably drive a few more kilometers since I still have some driving time left. I've charged to 93%, but it took a bit longer since the charging power was limited to 270 kilowatts. I lost about 20 minutes compared to full charging speed. Annoying, but better than having the charge stop completely or drop even further. You've got to be thankful for what you get. It's 7 p.m. now, and it's chaos at rest stops around this time. It was tough to even get back to my trailer, and when I went to hitch it, 2 other truck drivers immediately asked if I was moving so they could take the spot. Anyway, I still need to find somewhere to park tonight. I've got 42 minutes of driving time left, and I'm near Pforzheim, where I'm meeting Thomas. He was the first employee at Charge X and has found a rest area for us to meet up, have a quick chat, and enjoy a beer. I've arrived at my parking spot for the night, and I've set a new record today. I drove over 700 kilometers or 434 miles, and the truck still has more than 85% charge left. So, I'd call this nearly a perfect day. Sure, I could have arrived a few minutes earlier without the charging hiccups, but driving time was the limiting factor anyway. I pushed it right to the edge at 9 hours and 50 minutes, maxing out the 10-hour limit. My parking spot is peaceful but close to the highway, perfect for a good night's rest. Tomorrow I'll start at 5 a.m. and unload by 8 a.m. Today showed how practical and capable these e-trucks are for daily use. I arrived at the unloading site, which is a construction site, and my truck is being unloaded from the top. It's my first time opening the roof, and the mechanism is super simple, really convenient for the driver. I'm currently driving along the beautiful Lake Constance. I've already unloaded and now have a new pickup location in Ravensburg. Unfortunately, there's some traffic, so it'll take about an hour to get there. I'll be picking up 2 different loads for 2 separate delivery locations, all heading north. I'm at 43% battery and thought about stopping at the Aral Pulse charging station in Friedrichshafen. But since I'd arrive around noon, there's a high chance of having to wait. Instead, I'll head straight to the loading point. After loading, I'll hit the highway and charge at Ionity in Eichstätten. I saw in a picture that the site has a height restriction, but I've confirmed with my Ionity contacts that you can charge fine by entering from the back. Here's a scenario where the speed of this truck is a safety factor. There's a tricky spot here with a broken car, but I can overtake incredibly quickly, which avoids creating a dangerous situation. That said, there are a few software issues again. Last week, the truck was constantly beeping, but now it's completely silent. No sounds at all. That's obviously not ideal and should be reported. However, the quietness is impressive. Even in city traffic, you realize how annoying a turn signal can be when it's constantly clicking. Right now, this is honestly the quietest vehicle I've ever driven. At this logistics park, I spotted an absolute highlight, an e-Actros 300 charging while being loaded. This is exactly how it should work, making the most of every idle moment. There's a mobile charger connected, offering about 50 kilowatts. While that's not a huge number, using every minute efficiently really adds up. It's amazing to see this in action, even if it's likely designed for short and medium-haul routes. What's also fascinating is that it's a refrigerated truck, with an extra power cable running to the trailer. But it raises an interesting future possibility. What if trailers could draw power directly from the truck? That would eliminate the need for multiple cables. It's super inspiring to see the future arriving here. I've already driven quite a few kilometers this morning, and now the truck is down to about 20%. I'm heading back north, and my first drop-off is near Kassel, but I won't quite make it there today due to driving time limits. For now, I'm taking my 45-minute break. A big shout out to Adrian and especially to Christoph Strecker, the head of Ionity Germany, who's indirectly helping out because there are occasional height restrictions at charging sites. At this location, thankfully, half of the charging park is unrestricted. Hopefully, they won't decide to move the restriction to this side someday. These are ABB Ionity chargers, and I generally enjoy using them. Although the display says out of order, I was still able to activate the charger via the app. Now I'm charging at maximum power, and as long as the electricity flows, I couldn't care less about the interface. I always find it funny how the truck stands out from a distance, towering over everything. But you can also see how massive these charging parks are, with their transformer houses and all the rectifier racks fenced off in the middle. This spot doesn't just have Ionity chargers, but also a Lego, and at the front, Tesla superchargers. It looks like some construction is underway since new Tesla parts have already been delivered. I'd guess they're expanding with V4 superchargers, which will add even more options for charging. At these larger rest stops, there's no shortage of charging stations. Here you can still see the old rectifier racks, or DC racks, used with the superchargers. For Alpatronic chargers, these components are built inside the units, which is why they're so bulky and large. However, both Ionity and Tesla use standalone CCS stations, where the AC to DC conversion happens in a separate housing. These older racks are well known for being modular. You can even place them on pallets to quickly set up charging parks. You can see the old V2 superchargers, where one rack managed 2 charging stalls, meaning you had to share the power. With the newer V3 and V4 models, this issue is resolved. It doesn't matter where you park, as the power is distributed dynamically. I just arrived at my next stop, and things are about to get interesting since there are already a lot of trucks. But I drove 330 kilometers, or 205 miles, in exactly 4.5 hours, dropping from 83% to 30% battery. There's really no range anxiety with this truck. You never get into those lower percentages as long as you plug in regularly. Here's a sign showing there are still 59 spaces available. I'll need to pay €2 if I leave again and €12 overall. The €2 fee for dropping off the trailer is totally worth it. I just got back from running. I'm sticking to my plan to get some exercise in. The truck is still charging, making quite a bit of noise, probably waking up everyone in the nearby hotel. But I came across a truck I hadn't seen before, a Volvo FE Electric. It's likely a local delivery truck with a very small cabin and a 200 kilowatt-hour battery. It's a rigid truck, so detaching a trailer isn't even a concern for it. I totally get why it's parked the way it is. There's no other option. But with no electric cars around, I think it's absolutely fine. Seeing another electric truck, especially one designed for construction, is just awesome. I completed my first delivery at a farm equipment dealer. The vehicle you see in front of me is, I believe, called Acre from Evo Motors. It's a Munich-based startup that designed this vehicle for the African market, but it's also perfectly suited for agricultural businesses here. I think it's really cool to see it in real-world use. I'm now near Paderborn and could drive for another hour, but I'm taking a short break to make things more relaxed later. I'm now on my way to my second unloading point, and I have to say, driving through the country roads is a lot of fun, especially since the truck isn't fully loaded. I also want to add 2 points to the last videos. I was wondering why the truck has the function to turn on and off the side marker lights. In the US, this is used by truckers to communicate with each other, to say thanks, but in Europe we use the turn signal. So if you use the side marker lights here, people might think the truck is broken. But it's a cool detail that likely no other truck has. And when the truck was pulling 925 kilowatts from the battery, I said that it also had that much horsepower. But that's not correct. There's a difference between the power being pulled from the battery and the power that's actually converted into motion at the axle. With the e-axle, the electric motor, and the gearing, there are energy losses. So it's actually got 1069 horsepower as specified, but it has to pull more from the battery to achieve that. I'm now at the next loading point, and the trailer is empty. I was hoping they could load the goods today, but I just got the info that it'll be ready tomorrow morning at 9 a.m. It doesn't make sense to go somewhere else, so it's 2:30 p.m., and I'm calling it a day. The job is really tightly scheduled and super stressful, but then you get moments like this where the pressure eases, and you can relax and recharge. Plus, now there are plenty of good parking spots available. I drove to the next truck stop with decent facilities only 20 kilometers away, and I topped off the truck to 100%. This way, I know I can handle any trip tomorrow without issue. I loaded the trailer to max capacity just after 9 a.m., and now I've covered almost 230 kilometers or 140 miles. With the full load and a strong headwind here in the north, the consumption has been a bit higher. I'm currently at about 50% battery, so it's clear that it won't quite reach the usual 500 kilometers, but that's expected based on the conditions. I still have about 1.5 hours of driving time left, so I'm nowhere near the limit. On another note, the Iveco is back to its usual behavior. It had a glitch overnight, but now it's making blinking and beeping noises just like before. Yesterday, it also had a funny bug where the GPS location kept showing Phoenix, Arizona. That's probably the location for Nikola Motors. I've arrived back at the depot, detached and parked the trailer, and I'm about to take a walk around because there have been some exciting developments on the construction site. A lot has happened since I was last here. I mentioned before that the Iveco started making beeping and warning sounds again, but now it's quiet. There could be 2 reasons for it. 1, it might be a software glitch that's causing it not to make any sound. Or 2, it could be because I pulled the fuse for the amplifier, which would stop the sound. Either way, I'm just glad it's quiet now. The problem isn't so much the usual sounds, but with every notification, there's a beep. When the door opens, it beeps. It's all annoying. I also mentioned before that below 10% battery, It constantly beeps, which is incredibly frustrating. But the worst part is actually the air pressure warning. The pressure is still fine because I've just been driving, but once it goes below the threshold of 6.5 bar, you're not supposed to drive anymore. And of course it warns me about that, which is good, but it starts beeping as soon as the ignition is on, just when I'm sitting inside, even if I don't plan to drive. If I start it up and let it run for a few minutes, everything is fine again. But in this idle state, it's unbearable. It's really not acceptable, and I'm glad I've found a solution for it. In one of the last videos, I mentioned that the electricity from the open field solar plant needs to be transferred to the transformer, and these construction works have now been completed. You can still see the traces where the ground was dug up, and the cables have already been laid. It's really cool to see this trench. It has a lot of advantages. Often conduit pipes or cables are just buried, and whenever you need to access them again, you have to dig everything up. But this trench setup is great. It was of course expensive and complex, but with these elements, you can always add more cables, put the cover back on, and it's totally modular. You could add more charging stations, you could even add AC chargers in between, or remove a station if needed. It's a great system, and this approach could also be used for smaller AC charging points on other sites. Of course, the solar panels still need to be installed, but these steps show the gradual progress of the charging park, and I'm really impressed by it. Good morning! Today starts with the logistics company Bode in Rheinfeld. And here you can see the overhead contact line truck I'm going to ride in today. I have the great honor of joining the driver and sharing all the information on these trucks, and later speaking with Mark Bode, the owner, to get insights into the logistics side of things. This truck has 4 battery packs, each with 18.5 kilowatt hours, mounted in the chassis, and there's one more behind the cabin. The rest of the box houses the technology for the pantograph, which is mounted on top. We also have the usual components, like the diesel tank over there. That means the diesel engine under the cabin is the standard one from Scania. It's all slightly pushed back, so the saddle plate is further back as well. With the 74 kilowatt hour total, it offers an electric range of about 60 kilometers or 37 miles. You can see the R450, which refers to the diesel engine, and a small hybrid element, meaning this is a diesel hybrid vehicle. And off we go! You can already see that this interior is similar to the one in our electric Scania, so there are a few familiar details here. We're loaded with goods at minus 25 degrees Celsius, heading for Lidl in Finland. The battery is currently at 90%, with an electric range of 35 kilometers, though this gets recalculated constantly, based on weight and terrain. You can switch between electric and diesel drive at any time, and you can hear the difference when you do.
Ja, auf jeden Fall. Ich kann ja mal umschalten. Jetzt läuft der Diesel.
Ja, hört man. Most of the time, these trucks are driven electrically in ports or cities, where being quiet and emission-free is most important. But if the battery hits 0%, the diesel engine automatically takes over. We're now getting on the highway, and up ahead, you can already see the first sections of the overhead lines. Here's where the overhead line section begins. We turn on the lane keeping assistant, and the system uses GPS and other sensors to detect the overhead line, allowing the pantograph to extend. You can see the pantograph on the screen to the right. Now, the overhead line is charging the battery while also powering the truck for driving. If we drive without the lane keeping assistant and drift too far to the left or right, the system detects it, and the pantograph automatically retracts. The same happens when changing lanes to overtake. We have 2 fuel levels displayed, 70% for diesel, 95% for AdBlue, and the battery is at 88%. The system shows when the battery is being charged, but there's no indicator for the exact number of kilowatts being added. The test track is 5 kilometers or 3.1 miles long in each direction, and under normal load, we can recharge about 15% or roughly 11 kilowatt hours. However, with maximum weight, the recharging is less since more energy is needed for driving. This test track has been in use since December 2019, and this Scania was delivered in 2022. It has since covered 132,000 kilometers or 82,000 miles. Initially, the logistics company had 5 pantograph trucks, but now there are only 3 remaining. And now the overhead section is over, and we're back to running on diesel. We could drive all the way to the port on electric power, but it's more convenient to use diesel for now, and switch to electric when we arrive in the port and drive through city areas. 5 years ago, this technology was completely new, and there were software issues, but things have improved significantly since then. Interestingly, the most vulnerable part isn't the overhead lines, it's the vehicle itself. Occasionally, the pantograph fails to work, and the truck needs a full restart. However, there have never been critical issues. In the worst-case scenario, you just drive on diesel without using the overhead line. These trucks drive about 300 kilometers daily, which now matches the range of many electric trucks. Over the 5 years since this project began, a lot has changed. While the project initially showed promise, battery prices have dropped so significantly that it now makes more sense to have a fully electric truck rather than a hybrid with a pantograph, which is more prone to issues and repairs. For example, frost under the overhead lines can cause water to accumulate, and driving through creates a lot of sparks, leading to potential problems. Similarly, it's best to avoid using the overhead lines during heavy rain or strong winds. There was also an incident where a tarp got stuck in the overhead lines, and another where a large truck damaged the lines, causing the entire stretch to be shut down and unusable. One component that required replacement was the contact strips that connect to the overhead line. These are wear and tear parts. Interestingly, during a 3-month period when the trucks weren't in use, a layer formed on the underside that ended up damaging the contact strips. We're now at the port, dropping off the container. The container's clamps are being released, and then it's simply lifted off. It's a pretty straightforward process. Honestly, that stretch of 5 kilometers felt incredibly short. We chatted a bit, and before I knew it, the test route was over. The only difference from a regular Scania are the buttons. One for the pantograph, the camera, and a button to save all data from the last and next minute in case of any errors. Naturally, it's not a long-distance cab, since the pantograph takes up a lot of space. However, the height with the pantograph remains under 4 meters. We're now in Travemünde, at another port, picking up another container. This route is typically driven 5 times a day by these trucks, classic short-haul operations. Here, we can once again see the hybrid system, along with the casing that contains all the necessary technology, and on top, the pantograph from Siemens. I assume Siemens didn't develop this tech from scratch, but rather adapted it, given their extensive experience with trams and trains. Inside, you have all the power electronics to adjust the voltage for both feeding the motor directly and charging the battery. At night, the truck's battery is charged normally via a wall box. Electric trucks are already rare, but seeing one like this is truly special. And it's wonderfully quiet. It does raise the question of why hybrid trucks like these haven't caught on more. The ability to recuperate energy and feed it back into the system makes a lot of sense, but for some reason it hasn't really taken off. There's definitely room for a larger battery, and I was told earlier that the very first trucks in this project actually had even smaller batteries. As I mentioned, this project is over 5 years old, and these trucks have been operating here for several years now. It's interesting to reflect on the timing. Back then, CO2 neutral or electric trucks weren't really a priority. Now we have battery electric trucks with impressive ranges, and this would actually be the perfect time to combine the two technologies. Unfortunately, the timelines just don't align, which is a real shame. In any case, these trucks could definitely accommodate larger batteries. Theoretically, you could even eliminate the diesel engine entirely. At the end of the year, the project will end and the trucks will be returned. However, the company is already replacing them with fully electric trucks. Right now, we have 68% battery remaining. If we drive the full 35 kilometers to the overhead line on battery power, we'll arrive with around 10% left. While connected to the overhead line, the battery recharges about 15%. However, the charging is limited to a maximum of 19% of the battery. Even if we were stuck in traffic under the overhead line, the truck wouldn't charge beyond an additional 19%. Since the beginning of the project, there have unfortunately been no further technical advancements. The overhead line remains the same, and while the software has fewer issues, it's still the original version. The only real change has been the switch to a truck with a larger battery. We're now down to 6% battery, which is perfect timing as the overhead line is just ahead. With a truck that has a relatively large battery, charging could also happen faster. This means you wouldn't need overhead lines on every highway, but only on specific 10-kilometer or 6-mile stretches to recharge enough for another 100 kilometers or 62 miles. However, these lines are prone to disruptions and require regular shutdowns for maintenance. Additionally, they need to be turned off during accidents. We kept the pantograph extended and tested how the software responds when moving away from the overhead line. It reacts very quickly, making it almost impossible to misuse. However, in winter, snow can prevent the pantograph from extending because the lane keeping assist might struggle to detect the lane. And here is where the overhead line ends. We arrived with 6% battery and now have 21%. This is the spot where the truck charges overnight. The charging station is an older Siemens wall box with 32 amps and 3 phases. You can tell this truck has seen some years or was a prototype back then, as it features a flap with a button hiding the Type 2 port. Charging is done via AC only, meaning it has an onboard charger, likely with 32 amps and 22 kilowatts. This is sufficient for overnight charging and keeps infrastructure costs low since 32 amp connections are common on industrial sites, and these wall boxes are very cheap as well. Looking closely, you can also see how far back the fifth wheel plate is set, due to the space needed for the equipment housing. There's clearly room for improvement in compacting the design, as the space to the left and right isn't being utilized at all. In the parking lot, I found a second truck belonging to a colleague who isn't around today. I walked around it, and nothing major stood out, except for an additional frame with what looks like extra sensors. Otherwise, it's technically very similar, with the same drivetrain and battery packs. I'm now here with Mark Bode with his Ioniq 5N, but we're hopping into the new Volvo FH Electric to hear the final thoughts on the project directly from the CEO.
We've always approached this as an experiment that could succeed or fail. The biggest issue, however, is the lack of competition among manufacturers. Only one producer provides vehicles for this trial, which means there wasn't a race for technology. The technology itself works well, especially the infrastructure side, but that's just one part of the puzzle. We operate 90 trucks with a variety of technologies. We initially invested heavily in LNG, but have moved away from it and are now transitioning to electric, particularly for short-haul routes. As a logistics company, we have to be economically viable. With e-trucks, we can calculate the total cost of ownership and electricity prices. However, with the overhead line project still in its test phase, we don't receive any bills or electricity pricing, making long-term cost assessments difficult. This uncertainty makes it hard to determine whether buying an overhead line truck would be economically viable. Regardless of the technology used in the future, there needs to be planning reliability, which this project doesn't provide. For now, we've purchased 2 electric trucks to gather insights and experience on how to best integrate them into our routes. Since more manufacturers are releasing e-trucks, competition is increasing, and this should drive prices for e-trucks further down.
Today was really valuable, and I think you've all learned a lot. Now everyone can form their own opinion on this. It's funny how everyone has an opinion, even though they haven't really looked into it. But now we've established a few facts. And no matter what anyone thinks about this concept, you have to admit, as a tech enthusiast, it's pretty cool. This was a diesel hybrid truck that can recharge via an overhead line. Technically, that's just fascinating, even though these trucks are already 5 years old. Imagine what could be built today with much larger batteries. I'm really glad you tuned in, and I hope you'll join me again next time. And since I'm already up here in the far north, I'm going to spend my weekend at the Baltic Sea. I'll see you next time. Take care.